Good afternoon to all. So today in the second session with us, engineer Urbik Shah sir. He is a project manager at System Level Solutions Private Limited. He is having 11 plus years of experience in web-based applications and cloud technology. He's also having the 5 plus years of experience in managing and leading engineering team, defining architecture, managing SLS cloud frameworks like Nebula IoT middleware, Yelgar a real-time messaging framework, a LoRaWAN server, managing a certain SLS web applications. So he's having the more experience in terms of the field of IoT. Electronics and Communication Department, BVM Engineering College. I welcome you, sir. Sir, you can carry on your session and the session on IoT concept and architecture. Please, sir.
Thank you, Darshan sir. And also, I would like to thank Bhargav sir for inviting me as a speaker. So thank you, sir. So let's just start regarding the IoT. So let me share my screen. Okay, I hope all you can see my screen. Mainly, basically, I'm going to talk about mainly the IoT concepts and IoT architecture. I'm going to talk about the IoT cloud stuffs as well. But as Darshan sir has introduced me, currently I'm working as a project manager in system level solution. Mainly, I am handling the or leading the cloud department. So basically means I'm going to talk about more about the cloud. So what is the IoT cloud, means what are the features would be there. So mainly I'll focus more on that in this session. So this will be my agenda. So firstly means, as I mentioned, I'm going to talk about the IoT. What is IoT? And means at any time, if you want to ask any question, feel free to ask. So let's more have a interactive sessions. So rather than just for the simple webinar. So let's means you can ask anytime if you like to, if you have any question. So yeah, so means I'll start with the basic regarding the IoT. Many of you know about the IoT, right? But let's start with the basic first. So if some of you might not aware about the IoT, so he or she can understand about it. So then means I'll focus more about the IoT cloud. So regarding the IoT cloud technology stacks, IoT cloud features, types of cloud services as well. And then means I'll talk brief about the different application communication protocols. So that also I'll cover. And at the end means I'll show you different available clouds in the market, right? As Darshan sir has mentioned that at SLS means we are also having two cloud frameworks like Yelgar and Nebula. So I'll means discuss brief about those framework also during in our last slide. So to begin with means IoT. So like many of you means if you Google about the IoT, you will get the more specific technical definitions like this. Like many of physical devices are connected to the means can connected to the internet and then can share the data, right? But now if I want to give the very standard or non-technical definition, like so I guess means right now most of us are using the smartphone, right? So means previously we were using the phone, right? The keypad phone, which didn't have the internet. So what we can do means we could only chat, we could only send the SMS or we could only call, right? But right now means our phone is connected to the internet, so we can have a audio we can have audio calling, we can have a video calling, and also means we can read the books, we can watch the online movies as well, right? So you can consider that this phone is a internet of things, right? So this is how it as simple it is. So means anything, any physical things, which can collect the data or share the data, or that can do the both. So to be simplified means there are mainly three categories. So I guess the things, right? The things that can collect the information and then send it. Another is like things that can receive the information and act on it, and the things that can do both. So I guess in the first category, I guess you know many sensors are available, right? Let's say there are temperature sensors, there are humidity sensors, GPS sensors, right? There are soil moisture sensors. So there are many sensors are available. So what the sensors do? The sensors collect the information and then send it, right? They are sending to, let's say, to the radio frequency, they are sending directly to the cloud, they are sending directly to the private cloud, right? So means those things, those are the one category. I mean, that is called the IoT things, right? So those are the sending, those are the collecting the information and then sending. Another category is like receiving the information and act on it. So I guess what does that mean? Receiving the information and act on it means, if you means, let's say you are giving a command, right? So if you, let's say you are having a smart bulb or you are having a printer, right? So you are telling the means you are sending a command that turn on, right? So that that things is receiving the information and turning or turning off particular things, right? Let's say, to be simplified, let's say you are having a key, right? The key, and you are pressing the key, asking a car to open the door, right? Now car will get that command, right? And then it will open the door, right? So this is how very simple it is. Means this is how the receiving the information and it's act on it, right? And the things can do the both. Means let's say you are telling something. Let's say let me give one simple example like smart farming in smart agriculture, like. So let's say there is a soil moisture sensor. So what the soil moisture sensor does? So like it's collecting the information and sending to you, and it will tell you that whether your crop is needed to be watered or not, right? So means you will get an idea about that. Yeah. So this, yeah, my crop is indeed a needed of water. So you will you will turn on the water pump manually, right? And then you will get, means you will pass the water to a crop. But I guess the things that do both means, if you are sending the information, you doesn't need, means you don't need to do the manual things. You can automate these things also at the end application end, right? You can write certain logic that if I get the information during this way, right, I can automatically turn on my water pump, right? So these things can do both, means the collecting information, sending it, and also automatically you are receiving the information and act on it, right? So this is a simple example. So many of you will aware about the, means what is the IoT and the concepts of the IoT, right? To add more on that, I guess in previous session the sir has mentioned about the machine learning and the big data concepts, right? The machine learning concepts, right? So at the end also means you will write such a algorithms, like let's say you will add the weather API, right? So at the weather API, you will get to know that means tomorrow is going to have a rain, right? So why should I waste my water, right? Means automatically it will, means the crops will get the water, right, from the rain. So means those kind of algorithms you can write at the top of the end, at the application end, right? So it's not only the sensors and the things, right? If you know, means if you tell about the, if you ask about the IoT, it should cover all the categories, right? Or it can cover particular categories, but those things also can be told as a IoT, right? So I guess now means you will have the, means basic idea about the IoT and the concepts, means the three categories, right? If anyone have any query, means you can feel free to ask. So yeah, so now means this is those are the IoT, means those are the different categories of the IoT, right? But this is how actual IoT platform works. Means as I told you that the things can collect the information and send to it, right? But at the back end means uh, many of your nodes, many of your sensors will not have the capacity of the, let's say, the GPRS connectivity, GSM connectivity, or the Ethernet or Wi-Fi connectivity, right? So what means your sensors will do? The sensors can send the message, or your nodes can send the message to the particular gateway. So the gateway will have the all the capabilities, right? And the nodes and the gateways can send the message via the network protocols or RF protocols, right? So whether it can send the using the Wi-Fi, Bluetooth, the Zigbee, 6LoWPAN, right? Nowadays means LoRaWAN is very popular, right? So there are many RF protocols. G3PLC is there. So the nodes can send the message to the particular gateway. The gateway will have the capabilities to connect with the internet, whether it's means the internet or the intranet, means you can use any. And uh, they send the message, they send the particular information to the nebula, to the middleware, to the any IoT middleware. So the middle, what the role of the middleware? So the middleware will identify the data, right? They can also store the data if the any middleware has the capability. They can also store the data, and simultaneously means they need to manage all the devices as well, right? They need to send the alert, send the notification. The middleware need to configure particular devices as well, right? So those kind of means I'll go detail during the later slides regarding the middleware, the capabilities of the middleware. But this is means the overview of the IoT platforms. And middleware should also provide the endpoints, right, to develop any of the applications. So this is how means entire any IoT platform works. If your node has direct capabilities to connect with the business logic or middleware, right, they can directly send to it, right? The Those are the means as in previous slide, previous speaker also mentioned about the different protocols as well, right? So use from the application level protocol, right, the gateway to middleware, right? So we can use the any TCP protocol, UDP, MQTT, AMQP means, right? And at the end also means from the middleware to end application also we can use any protocols like REST, MQTT, HTTP, or any COAP protocol, right? So means this is how the this is how the basic IoT platform works. And so means before coming to the cloud, I'm gonna talk about more about the different IoT applications, right? Different IoT use cases in brief. So you will get an idea about this, how it's useful. Means in which sectors the IoT currently we are using the IoT, and IoT can be useful. So those means you will get an idea. So these are the means basic sectors that IoT has been using. And so whether you can means whether you can see about the in transportation, smart transportation, smart farming, in smart grid, right? Industrial IoT, wearable, in smart home. So in this means these are the popular IoT applications, but there are many more. So different IoT applications, maybe we can use the IoT in different kind of sectors. So let's talk about brief about the smart home, right? So I guess as you can see in the many of you might aware about the smart home, how smart home works, right? So let's see, as simple it is, right? You can control your home appliances remotely, right? But actually how it works, so let's say you are having a different home appliances like smart home appliances, right? Whether it's a bulb, TV, right? AC, air condition, your curtains, right? So how means how it works, so that those smart curtains or those smart bulbs, right, are connecting with means widely Zigbee protocol, Wi-Fi protocol, Bluetooth, RF protocol has been using smart home and smart building kind of things. And also means nowadays LoRaWAN also has been widely using. So those kind of appliances will be connected to the your gateway. So your gateway will particularly, or your hub, you can say as a hub, your hub will send the message to the cloud, right? and your cloud will have a endpoints, right? And at the end means you will write means you will write the logic, right? Let's say particular events also you can mention. IFTTT also, if you have heard about that, events also can be mentioned. Like let's say if my room temperature goes below, right? So my AC should automatically turn off, right? Or if I enter the room, like my light should automatically turn on. If I leave the room, my light should automatically turn off. So this kind of events also you can you can manage at the end application side. So this is how the smart home actually works. So means if you will get a chance, just go on the consist.com. So at our SLSN means we have developed one product called Consist. So you will get an idea about the what's the smart home and all is about. Another means it's like the smart street light. So means nowadays government is adapting these smart street light things, and means in each of the street lights there will be a controller, right? So the controller will directly send the message to your remote server, saying that means many advantages using this means you can control all the means the management can control all the street lights remotely, right? You can means save your energy as well, right? The consumptions as well, right? You can find the if there is any if there is any something wrong in the particular street light, you can manage this as well. So yeah, this is another use case of the smart street light. So this is also widely used. Another thing is like the smart metering, like automatic meter readings, right? So in in Western countries, this also has been applied to different residents. So like in your meter, there will be you can add particular sensors like which will be automatical meter reading. So that will tell you on your mobile application that currently uses of your meter, right? So if your consumption. So this is also means widely used, this smart meter things. This is again means very popular like smart grid, right? So again government is managing the different electric grids, right, using the IoT kind of technologies. So not only the particular home meter things, but also means government is managing the different homes or different residents, different commercials meters as well, the consumptions as well, right? And also means nowadays this solar, the renewable energy concept is there. So we can also means manage the particular panel wise consumption as well regarding means in the renewable energy field. So this is another sector that the IoT is very helpful. Means many of us are aware about the healthcare sector, right? So I guess that simple it is means nowadays in smartwatch, right? You can easily manage your heartbeat rates, right? Your means how many steps you are means you daily walk or how many steps you cover, right? Your temperature as well, right? So this is in healthcare system also means the IoT is widely used. I have already given one example of the farming as well, right? So in farming, smart agriculture also, as I mentioned about the, you can monitor real things. Yeah, you can when collecting the big data, you can analyze certain things, right, at the top of it. So in smart dairy side also, you can use these IoT concepts. This is also widely popular sector, means smart transportation. So in smart transportation also means you can manage means there is a GPS sensor. So the main basic use case I guess you can manage is the locations. So you can track certain means you can track a particular vehicle, right, remotely. So there's also you can means there's also the IoT can be very helpful. Also means inside the any vehicle as well means you can use any sensors, right, to know the health of the particular vehicle. To get to know the health of the particular vehicle, you can use as well. So this is how the means smart transportation works, right? In many means let's say in currently the government is using in the different school buses as well, right? So in any kind of transportation, we can use this kind, means we can smart particular things. So that it's advantage. I guess there can be a certain disadvantage of the IoT, but let's talk mainly about the advantage, because there are more advantage than the disadvantages. So yeah, so these are the means different sectors. So the IoT means we can use IoT, or we can get the advantage of the IoT. So yeah, so before going into the more about the cloud stuffs, right? If you want to have any, means if you want to ask any questions regarding the concepts or architecture, means you can ask. Yes, sir. Any questions so far?
No question, sir. I think
Yeah, thanks.
at present, if any question, let it be available on chat box, or someone can unmute themselves and ask question.
No issue. Yeah, thank you, sir. Yeah, so let's talk about mainly about the middleware or cloud stuff, right? So as I mentioned to you that these are the different things, right? Whether it's mobile or any sensors, right? Whether it's any device, right? And these are the different applications where, as I mentioned, different applications, right? Any smart cities or smart farming, right? But in between means the IoT platform, or let's say the middleware can be used. So means if you can see the basic use case or basic feature of the middleware, right? So I guess the main feature will be the connectivity, to providing the connectivity between your things to your end applications, right? And another basic feature would be like to provide the communications, right? To send, to pass the message to from your device to your end application, or from end application to device, right? So these are the two basic features of any IoT cloud or any IoT middleware, right? Means on top of it, or on in middleware, there can be a many features, right? But as you can see that the primary task included the data collection from the devices and provide the collected data to the end devices. So these are the main basic features of the any middleware system. But as I mentioned, there are many more features that can be have in any of the IoT cloud. So I guess it should collect the data, it should message, right? It should manage the identity, right? It should have the configuration management. It should have the OTA software updates, right? It should also have the high infrastructure as well, right? So let's talk about the communication part. Now, communication in the sense, let's say I want to connect, let's say any things want to connect with any of the middleware, right? So it should provide the proper SDK, proper connectivity, right? It can use any of the application means protocol, right? Where both your device should support that protocol as well, right? So it's basically the middleware is basically the mediator, right? And the main important thing is the communication part. So it should also handle the multiple connections as well, right? So this is how the communication works. Another means basic feature is like the identity management, or you can say the device management. So any IoT middleware should have this device management feature. It should handle multiple devices, right? It should also know the presence of particular device, right? Whether your device is online or offline, right? It should also get the acknowledgement, right? Whether you pass the message to particular device, whether it has been received or not, right? So this is how, means this is the management stuff should also there in any of the IoT middleware. So this is also a one feature that any IoT middleware should have. Another thing is like the messaging. So I guess the messaging is also very important, because if you talk about the security aspects, right? So your middleware should provide the security as well, or in terms of the payload security as well. So the messaging is like it should provide the whichever the data type you want to pass your message, right? whether it's a string, right, whether it's in the binary form as well, right? So that means your middleware should have this kind of features, like the messaging kind of features, or it's not means it should be a flexible. Another thing is like the data collections. So data collection means if you want to apply particular algorithms or particular AI, right? If you want to collect, if you want to apply particular AI, but before that you need to collect the data. Then and then you can apply certain algorithms, right? So it's called the means it's called the big data, and then you can apply certain algorithms. So those kind of features should also have in any of the IoT middleware, right? To collect data, right? To provide, to give the endpoints to any kind of algorithms or any kind of AI endpoints, to have this kind of capabilities. So this is also a main important feature of the data collection. Many of the IoT middleware are also storing raw data also, right? So those kind of features also will be helpful. Also means many IoT middlewares also have the acknowledgement kind of features as well. So whether your device is getting the message or not, right? So those kind of features is also there. So this is the data collection feature. So another is like the configuration management feature. So I guess the configuration management is like, if you want to, let's say you are having a device, right? So if you want to configure something, right? So your middleware or your cloud should have that kind of feature, right? Let's say if I am having my device, right? If I want to update any of my configuration, it should just simply write the particular configuration command, and automatically my device should configure that kind of thing. So this kind of feature also should have in any IoT middleware. Apart from it, like the software over there, right? So the software update. So many of you in our firmwares also means if you want to update our firmwares remotely, means any middleware should have this kind of facility. So these are the means features, main features. So most of means middleware should have. If you means if you ask about any IoT middleware, right? So I guess these are the features. If you have, then you can you can execute your end application very easily. If you're talking about us, means we have been in this IoT field. We have working on many different IoT applications, right? But this kind of features, I guess, is very important because at larger end, at the scalability end, right? You will need this kind of features. Apart from this, means there are certain advanced features as well, right? If you talk about the cloud, right, it should have the scalable cloud, because let's say currently you are having only few thousands devices, right? At the later on, means if it increase, right, your cloud should increase automatically, or your cloud should have all kind of let's say high availability, clustering, mirroring things, failover things, right? So at the end, means at the executable layer, or if you deploy any particular things, right? So your cloud should manage automatically. Another thing is like the customization. So let's say right now your particular device is sending the message with a particular, let's say, string, right? JSON string, right? But if you want to change with another thing, it should provide the schemas, right? Right now, if your data schema is currently fixed, right? But if you want to change that later on, your middleware or your cloud should have those kind of facilities, right? So you can change it easily without affecting the deployed certain devices or your deployed endpoints. So those kind of features are also helpful in any of the IoT cloud. Another thing is like the security. Means right now this is a very hot topic to say about the security in IoT. Means many of us are thinking that we can easily hack any IoT devices, right? But I guess it's basically it's not true. We can apply any kind of means we can apply particular security kind of things, so that we cannot hack any particular things, right? So I guess we can apply few things. Many of you have heard about the end-to-end encryption, right? I guess in WhatsApp also means few years ago they have introduced the end-to-end encryption. So basically how it works. So many of you might aware about the end-to-end encryption. So I guess you need to encrypt your message from the client end, right? And your another client will can only decrypt those messages. So your entire network will have the encryption payload, right? So this also security aspect you can apply in your applications, right? There are many algorithms like AES, right, RSA. So you can use those kind of algorithms to have the data security, right? Another thing is like the transport layer security, right? Those you can apply using the SSL kind of thing, like secure socket layer. So you can have the SSL certificates, right? The public key, private key concept, and you can have your network secure. So you can have the data encryption, right? And on top of that, you can also apply the SSL kind of things. So you can get the security as well, right? So also you can have your device authentication properly, because it should not have the straightaway connection to your device, right? It should have some kind of logics, right? And then your device, your things can connect to your middleware or your cloud, right? So this all kind of advanced features also you can have or you can apply in means in any of the IoT cloud or any of the IoT frameworks. Yeah, so mainly means these are the few IoT cloud features, and IoT cloud means advanced features as well as the basic features, the main features, right? So yeah, in this means if you have any questions, yeah, you can ask. Else I'll move to the another topic, which is like now means you are aware about the cloud, but I guess which type of cloud you should use, right? So you should also know about the types of cloud, the different cloud services, right? So all kind of things means you need to taken care before choosing any cloud. Yeah, any question? Yeah, Krunal, I guess Krunal has one question.
Yes, Kunal Vyas, you can speak.
Okay.
Yes, sir, you can move forward.
Yeah.
We can take a question at the last of
No,
session.
thanks. Yeah. So now there are certain types of clouds are available in the market. So means many of you might not aware the actual definition or actual name of particular cloud, but many of you are using those kind of clouds already. So let's talk about the public cloud. So there are four kind of means clouds available, like public cloud, private cloud, hybrid cloud, community cloud, right? So basically the public cloud, what's the public cloud? So public cloud basically means, I guess, on somewhere else or at the publicly, let's say there is AWS available, right? AWS, Amazon clouds are available, Google clouds are available, or any Azure clouds are available, right? So on in those kind of cloud infrastructure, right? You are running or you are using those cloud infrastructures and deploying your own applications, right? So this is called the public cloud. Also means on if you have your dedicated cloud instance, reserved cloud instance, right? But you are managing your application to the third party cloud provider, which is the publicly available to others as well, either by sharing or if you can get the reserved instance as well, right? So this is how the public cloud, this is called the public cloud. Another means there are certain pros and cons of the public cloud, right? The means pros is definitely means you can get the IT resource whichever you wanted, right? You can deploy it easily, right? Also, it enables the scalability option as well. If you currently need a 4 GB RAM instance, right? And later if you need the 8 GB RAM instance, means many of the cloud providers are currently giving that kind of flexibility, right? So it's means I guess it should easily work your application. But the certain cons are like though means you are deploying your own application, but you are deploying in the third party providers, right? So I guess the various attacks kind of things, I guess it should be in your mind. But many of the right now the cloud providers are covering this kind of cons as well. So I guess it's widely popular to use this public cloud nowadays. Another is like the private cloud. So let's consider that if you want to have the private cloud, if you want to have certain things in your own premises, right? Whether it's shared to your shared privately or the dedicatedly, right? So you can also have your cloud infrastructure privately, right? Whether it can be in the cloud as well, it can be in the on premises as well, right? But yeah, this is another types of the cloud, the private cloud. And the main con that we consider as a private public cloud, you can cover in this way, like you can apply the security, whatever hardware security or the any pen attacks, right? So that you can manage because it's a privately manageable by you. So this is one another type is called the private cloud. As I mentioned, then there are certain pros and cons as well, right? So you can manage your private hardware, yeah, right? Your physical servers as well. But I guess it's mainly the very much costly if you compare to the public cloud, because what they are doing, the AWS and Azure and Google's are doing means they will give you as a share cloud, right? So I guess if you want to have the private cloud with the very scalable private cloud, I guess it's cost you high compared to the public cloud. But that's why you can use also the hybrid cloud as well, right? If you have certain kind of let's say certain kind of things like have a security purpose kind of thing, so you can use in a public cloud as well, right? Or if you have in certain kind of things, you can use as a public cloud as well or private cloud as well. So here you can manage both at a one time, right? And you can design as a hybrid cloud. So based on your application means you can choose any of the cloud, whether it's a public, private or hybrid cloud. So yeah, so there are certain pros and cons as well, right? Of the hybrid cloud. And another is like the community cloud. So I guess means in public cloud and private cloud both, right? So you can manage as a certain organization wise or community wise, right? If we want to manage with the, let's say all the BVM users should use this cloud, so we can use as a community cloud, right? Or if you want to manage certain, let's say the certain organization should use this cloud, or they can interact with each other, right? So it's called the community cloud. Both in the private and public, we can manage this kind of cloud. So this is another means this is again the pros and cons of particular community clouds. The main advantage or main disadvantage is like it's not for the every organization, because it's as per the use case you can apply this kind of cloud. So these are the mainly the types of cloud, right? But if you choose, let's say you want to design a particular, you want to develop a particular IoT application, right? Or you want to develop a IoT cloud infrastructure, right? So you have your applications, right? You have your cloud type, right? But what it's a services means many of you might have heard about this kind of terms, right? The software as a service, the platform as a service, the infrastructure as a service, right? So basically these are the three kind of services the cloud model is offering. If you talk about the software as a service, so I guess it's also known as let me give one simple example is like, let's say you are using the Gmail, right? Or any of the portals, right? End portals. So what you are simply accessing by their web portals, or either from the mobile app, right? Whether it's a Paytm, right? Whether it's any PayPal or any kind of things, right? So what you are doing is you are using the software service, right? And you are using the service to get your work done, right? So this is known as a software as a service. It has been developed or deployed by some another company. It can be deployed on some another cloud, but as a user, you are using its service only. So it's called the software as a service. Another thing is like the platform as a service. So if you would like to design any particular platform, right? So those kind of platforms, let's say AWS is giving its database, right? So using the database, So you still need to develop particular applications, and you still need to use those database, right? So those are the giving the platforms to design your applications. So it's called the platform as a service, right? So many of the cloud protocols also means you will get from the market. So they will give you the particular platform, not the direct software to be a direct software to use it, but you can develop your own applications using those kind of services platforms. So it's called the platform as a service. And another thing is like the infrastructure as a service. So means let's say there are certain, as I mentioned about the public cloud, right? So there are certain public cloud providers are there. So what they are giving you, they are giving you the infrastructure, right? If you tell about the, let's say in PC also you can deploy, you can consider as an infrastructure, right? So if you ask for any system, right, whether it's a 32 GB RAM system or 8-core CPU, right? So it provides you the entire infrastructure, right? And on that means you need to deploy your applications, yeah, you need to deploy your components, right? And then it is called the infrastructure as a service. So these are the mainly the three services which are there in the market, means which we can call as a software services. Okay, so regarding the clouds means you must have means get an idea about how IoT cloud works. Means I've already told certain features as well, right? Means basic feature, main features, also types of cloud and services, right? But the main important thing is like the application communication protocol. So you must have heard, or many of you might be using these protocols only. There are many more protocols as well, right? There are there is AMQP, there is XMPP. So there are many protocols as well, right? But mainly these are the widely used protocols, and I guess there are certain advantages, disadvantages also. If you consider these protocols as well, right? So if you consider the TCP and UDP, right? So both are the widely used protocol. TCP means you can always means you can connect your socket, right? And your connection will always means your connection is connected throughout the transport layer, right? You can get the acknowledgement, right? So it's a very important protocol. UDP you can use means it is not sustaining your connection, right? But you can use UDP where you don't require means if you don't need to worry about the security, right? It's a fast compared to the TCP, right? Or you don't require to have the connections each time. So in that case, the UDP you can use. MQTT means it's very widely known application protocol, right? It is developed on top of the TCP. So it provides you the channel kind of things, right? Well, you can mention the channel as well and topic channel as well, and you can design any particular application, right? Also means that this is the HTTP protocol is also there. So that REST HTTP protocol you can use. COAP protocol is also widely using in the WSN point of view also, or in the application point of view also. So these are the mainly widely used protocols. I guess in all these protocols you can apply the securities as well, right? Many of you might know about that SSL security, right? So well, we are usually with few websites means we are seeing with HTTPS, right? So these are we can apply on top of this protocol the security aspects as well. So these are the basic protocols. I guess in the next slide, I guess one of my colleague will cover more about the protocol stacks. So you will get an idea about the different protocols in detail as well. So yeah, so these are the different application protocols. But these are the things you need to take care before choosing any protocols. Means whichever the programming language means you can use, right? But you need to make sure that means which protocol you need to use. So you should consider these aspects, right? It's the minimum packet rate, which should be must in any IoT applications. like it should be highly secure. The security kind of things it should cover. Another thing is like the deliverable assurance, right? So you need to get the acknowledgement as well, right? Whether you send your particular message to your middleware, right? It should get or not. You must need an acknowledgement. Another thing is like it should be a less connected less connection and transfer time, right? So it should be fast. It should be a real time and fast. So those also you need to consider before choosing any of the protocols, application protocols. Another thing is like it should operate the lower bandwidth, right? So in many of our devices might not have support of the 4G, G4G, GSM, or any Ethernet Wi-Fi, right? Many of the low bandwidth devices are already also running in the 2G, right? So it should also support the lower bandwidth as well. It should consume the lesser power, right? So your battery consumption also should be there. Means it's also a main priority of any of the IoT devices, because at the on field means you will not means it should support the long life battery. So you will not go there and change the batteries each and every time, right? So these kind of things also should be considered before choosing any of the application protocol. So these are the few factors you need to consider before choosing any application protocol. And so mainly this IoT, these are the few IoT platforms. These are there in the market. You can means if you check about the AWS, there are hundreds of platforms, right? If you search about the IoT platforms or IoT cloud in the market, right, you will get hundreds of platforms, right? But these are the highly used platforms, right? The fifth and sixth, I'm gonna talk brief about it because it's our SLS frameworks, right? And those frameworks also can be used in any IoT framework, any IoT applications, right? But if you check about the AWS IoT platform, right? So in AWS also means there are number of products, right? There are many products of IoT as well, right? But the main core product is like the IoT core, right? Whether there is a device management, right? They are giving you the few SDKs to play with, right? To connect and publish and subscribe, right? Same goes to Azure and IBM and Google as well, right? And means you will get certain free accounts as well, where you can play with you can play with certain connections as well. So you can simulate certain devices, you can get the messages, right? You can check in dashboard as well whether you are getting the particular messages or not. So all the things you can work on in any IoT platform. So yeah, so the below two are as I mentioned is our two couple of frameworks, right? So let's have a brief discussion on these two frameworks. Means the one is the YALGA. I guess many of you we have already given one session in few sessions since BVM as well. So many of you might aware about the YALGAR and Nebula, right? So mainly the YALGAR is a real-time messaging framework. So let me show you one simple example, right? So let me share my window again. I guess it's visible, that YALGAR website.
No, sir. No.
Yeah, just a minute. Okay, so I guess it should now visible, the YALGA.
Yes, sir.
Okay, so yeah, so if you search about the yalgar.io, right, so you will get this real-time messaging framework. So basically it's a framework, right? So you can connect, you can publish, you can subscribe, right? So this is one simple demo that I would like to run. But before that, just have this video so you will get an idea. It's means we are giving our free plan as well. So means whichever student or whichever one should want to use, they can use as well. So just this is a 1 or 2 minute video. So let's
In today's fast-paced business world, many platforms use real-time messaging apps and live dashboards for seamless communication. But developing such highly effective platforms with support of real-time messaging, low latency, and high reliability is a major challenge, as it not only requires expertise, but also your valuable time, money, and infrastructure. Luckily, this is where Yalgar can help. Yalgar is a real-time messaging framework that offers highly scalable publish-subscribe message infrastructure on cloud. It offers services to send messages and notifications to a single device, groups of devices, or broadcast to all the subscribed devices in the messaging framework. With cross-platform messaging communication support for all the major programming languages. Unlike traditional messaging frameworks, Yalgar offers a collection of features to meet all your communications needs. Yalgar provides publish, subscribe messages, and presence notification. With Yalgar, you also get advanced features like offline messaging, webhook, security, and push notifications. Whether you're developing social networking sites, real-time tracking app, a multiplayer game, or IoT and M2M connected devices, Yalgar has everything that you will need to build your app. To get started, simply download the SDK and copy the sample code. Within minutes, your users will be able to send real-time messages and communicate with each other quickly and conveniently. Start developing your website or app with our unified platform today. So what are you waiting for? Get your free trial now.
Okay, so mainly means I just want to say about how this platform or how the IoT platform actually works. So mainly means we have one demo. So if I can show that demo to you, so it will be easily understandable means how this IoT platform can be used or work, right? So yeah, so you can also play with it, right? So means this is we have developed just for the demonstration, right? So if if I can scan this particular code. Okay, so what I have done is like I have scanned this code, right, and I'm getting the control of my this dashboard, right. So using the remotely, I can access my means this is simple this GUI compliance or components, right. So let's say I'm turning on my lights, right. So you can see that my light has turned on, right. So if I'm means using this mobile applications, right? If I'm turning on my TV, right? So I can also turn on my TV as well, right? So as you can see that I'm turning on my TV, right? So if you can turn on this fan, right? So if you can see that the fan is turning on, right? So using this mobile application, I can accessing this. Just consider that this is your real home appliances, right? So what you can do is like your real home appliances will connect with any IoT frameworks, right? With any IoT devices, right? And those devices will send the message or to any IoT cloud, right? And using the mobile application should also communicate or mobile application should know that let's say I just want to turn on my fan, right? So using this any applications, right? You are sending a command to any of your compliance. Let's say you know that this device is running on ABC, right? This is the device ID is ABC, right? So you are just giving the command to ABC device, right? What your middleware will do, your end application will do. Your end application will send the particular gateway. Let's say to turn on my ABC device, right? And the middleware will send the device to your gateway, right? And your gateway will send the command to your particular ABC device. Let's say to particular your fan, and your fan will automatically turn on or turn off, right? So this is one simple example. Just I want to show you. So this is how entire means this IoT framework works. So this is a home automation example, but you can means apply in any of the IoT application sectors that we have just discussed before. So yeah, so this is one simple demo, right? If you would like to start as in a previous session means someone was asking about the to start platform, so you can start easily, means you can just simply download the any SDKs, right? It has the sample codes as well, so you can just connect, right? You will find the SDKs, whichever the programming language you want, the all the SDKs are there, so you can easily means get the SDKs. So another platform is like the another platform is a Nebula platform. So I guess let me share my screen again, window again. So yeah, so this is also another framework, but as I mentioned that the Yelgar is means mainly on the messaging stuff, but it should provide the whole entire frameworks. Means if you want to design any of the IoT use case or application, right? So it should means it is providing the node, gateway, middleware stuff as well, right? We are also manufacturing devices as well. So yeah, so you can also check this out, right? To understand more about the IoT. Means at this means many of you are student, so you will get an idea about how IoT works, right? And means what to use in IoT cloud, IoT framework. So in this means you will get an idea. So yeah, so this is just a minute, yeah. So yeah, so these are the few basic examples. If you want to ask means any questions, right, we can have the question answer session. So I'm basically just I want to share a few things about the clouds, IoT basic, what is the infrastructure, cloud infrastructure, and the how IoT works. Yeah, any questions so far?
I think nobody's asking the question.
Yes.
You can go ahead.
Yeah, so so that's means it about my. There are many more things, right? We can cover, right? Means I can show you real demos as well, right? But I guess in this session means I just mainly want to talk about the basic things.
Yes, sir. We have one question. I think Parul is asking that what kind of coding we should write to connect device with middleware and IoT platform.
Okay, so miss it's entirely up to you. There is no specific that you need to write your application in certain programming languages, right? So let's consider that these are the application protocols I have talked about, right? Regarding, let's say your middleware is supporting the MQTT one, right? If you want to choose Python, if you want to choose Go language, if you want to choose .NET, Java, right? If you want to choose JavaScript, right? You can you can easily get the programming languages SDKs, right? The client SDKs, right? Using those SDKs, you can communicate, you can communicate with the middleware, right? And the middleware, any middleware will give you the endpoints as well, right? So whether it's a REST API, MQTT, Kafka, right? So it's middleware things that they will give you endpoints. But from the device perspective, you can connect with the POSIX-C as well, right? Any embedded device, mostly embedded devices are also providing the different socket libraries, socket SDKs, right? If you choose TCP, if your middleware supports the TCP connections, right, you will get the TCP SDKs as well, right? You simply need to write the message or read the message from the TCP socket, right? So yeah, it's not any particular language. It's entirely, yeah. I hope that answer your question.
Any other question from the participants?
Yeah, hello, anyone having any questions? You can type even though in a chat box.
Mr. Urmik, I have one question.
Yes, sir.
Uh, so far we have discussed on the wireless platform, but
Yes.
in this, can we focus then that TCP at some extent can be utilized as a wired connectivity also?
So yeah, so mainly means in our later sessions, and you means those things can be covered, right? But the mainly is in IoT frameworks, right? So this is the wire technology, means you can send the message. I have also mentioned about the G3 PLC stuff as well, right? So yeah, so you can have the wireless, means you can have the connectivity as well, right? But this is mainly for the wireless stuffs where you can send the message, right, from your any of the device which can support internet, right, or intranet, right? And wirelessly means you won't require the wireless, you won't require the wire connectivity, right? Wirelessly you can send the message from one end to another end. So these are the widely application level protocols. Those are the wireless protocols, the socket communication protocols, right? So those are the mainly works between the bidirectional communication, right? So where you connect from one end to another end, right, using the wireless protocols. And then means at the end and at the remote end means you just need to play with it, right? So in many of the applications you will find as this wireless protocols are very useful, because certain things you need to control remotely, right? So it won't be there that at the deployed end or at the at where your device has been deployed, you will do certain kind of things where you will get the connectivity with wire, right? So yeah, so mainly this is the very useful means IoT cloud. These protocols are using as a IoT cloud. So this is wireless protocols.
Yes, sir. We have another question that if you are using IoT platform, then this kind of connection like middleware coding will be taken care by platform or programmer should write the script.
Okay, so that's a good question, because let's say if you talk, if I also in my last slide means I have mentioned different providers like the IoT framework providers. So those IoT framework providers means that they won't give you the end applications. So what does that mean? End application means, let's say this home automation stuff or smart meter stuff or any transportation stuff, right? So they will mean, that's why I have included all the features of any IoT middleware as well. IoT middleware. So it should provide, the main features will be, it should provide the connectivity and the messaging, right? Uh, at the apart from it means whether you like to have the design the dashboards, right? Whether you like to have certain algorithms, AI, right? So those kind of things application should manage, and application should manage. So let's consider that I want to turn on something, right? So those the middleware will only the pass through particular messages, any middleware, right? Any IoT platform. But at the end application, it should provide the proper endpoints. Let's say it should provide the REST API stuffs. If it should provide the MQTT socket stuffs, COAP endpoint stuffs, or any any means endpoint stuffs. So using those endpoints, you can design some particular applications, right? So let's say if you want to send message to your device, right? So your middleware should provide the APIs, right? So whether you can pass particular message, but middleware won't decode your message, right? It should only pass through a particular message, but the decodation and all the stuff the end application should manage. Many of many of the companies are also providing the middleware and also the whole ecosystem as well, right? End-to-end application. But it depends. But generally, most of the IoT platforms are providing only the connectivity and pass-through. And apart from it, the another features like I mentioned, like firmware over there, device management, presence, right? The configuration updates. So yeah, so these are the main role of middleware.
Yes, we have another question that in what way IoT technology will help the poor rural people?
Okay, yeah. So it's again a very good questions. So mainly means right now there are certain RF protocols, right? So I guess LoRaWAN, many of you have heard about the LoRaWAN technology. So what LoRaWAN technology does is like it's a long range technology. So let's consider that we have one rural area, right? So where we don't get the internet connectivity, right? So what we can do is like we can deploy, we can use the LoRaWAN technology here. There is another NFC technology as well, right? So it's a long range technology where if you are deploying particular message, particular sensor here, right? So it should cover the 15-kilometer range, right? Using the radio frequency, from your sensor to you can deploy your gateway in such a place that you will get the network connectivity, right? So your sensor will send the message to the gateway, right, using the radio frequency where you won't get the data, right? Won't get the internet, right? And from the gateway you can easily send the message to the end applications, right? Because your gateway will have the internet connectivity. So yeah, so using this kind of technology, another is like the direct. If we can use direct satellite technologies as well. So yeah, so this is how the IoT technology can be deployed in rural area. But there are certain use cases as well, right? So where in the rural also we can use the IoT in means to get an advantage, right? I have also explained you different applications, right? So any applications can be used in means many rural area as well, right? Like we can use farming in agricultural farming as well, right? So yeah, so I hope this answer your question.
Then we have one more question that I want to study IoT in detail. From where should I start?
Okay, so many of have means this kind of perception is like IoT is I guess it's very easy, means if we just want to have one device, if we want to have just one IoT frameworks or middleware, right? And if you want to design certain end application, right? So I guess it's very simple. It's very simple to use, right? But at the end application means if you want to design particular things, if you let's say if you want to develop any use case, right, in depth, right? Let's say if you want to develop a street light or if you want to develop a home automation, right? So in that end you need to manage all the stuff. If you need to manage the events, you need to manage the controlling stuffs as well, right? But if you want to start with, right, you can start with any basic device you can use. If you don't have a device, right, you can use your web application or Windows application as a simulated kind of things, right, to act as a device, right? There are many open source frameworks are available, and using those frameworks you can use as a SDK in your simulation, and at the end means you can fetch those data and store in the database, right? So yeah, so you can start with the basic, and later on means once you get to know the basic things, then you can move forward with the advanced things like the scalability kind of things, like the security kind of things, right? But as I told you regarding this Yalgar means it will give you the SDKs. You can start with those SDKs, right? and you can get the message, and from this message you can play with those messages, or you can store with those messages.
Yes, sir. We have one more. That can you give us more free bots available for communication apart from the Telegram?
Yeah. So to talk about that free bots available to communicate apart from Telegram, right? So yeah, so there are you can find many this free bot chat applications as well in connectors as well, right? So you just simply apply those connectors, right? I'll send you those leads as well, right? You just need to apply those connectors in your end applications, right? And using any kind of this messaging communications kind of things, right? You can use those free chatbots in your applications, and at the back end you can use any kind of messaging frameworks. So using those frameworks and using those free bots, you can manage your end applications. So one another question I can see is like, is IoT more related to computer science or electronic and communication? So I guess as I told you in the beginning as well, right? So IoT is not only dependent on any particular, let's say any particular technology or any particular field, right? Whether it's a computer science or electronic communication, right? It's not only more about the things and the sensors, right? So as I told you in the beginning that there are categories, right? So the things that connect the information and send it, that is one category. That is also called the IoT. The things can receive the information and act on it, right? That is also called the IoT. The things can do the both, the receive and act. So you can develop any web application, business logic, right? That is also called an IoT, right? So if it's not specific to any specific field, right? It can apply everywhere, right? If I already mentioned the example of any this smartphone, right? This smartphone also you can say about its IoT device, right? So it's not only stick to any sensors or device. If you apply different algorithms, AI algorithms at the end, right? It should also it is also one category of the IoT, right? So it's not only it's not dependent or to particular any field.
Very much for your wonderful session, and it was nice startup for the IoT, and people participation get a good basic concept of the IoT and architecture and protocol. So participant, the next session is going to be start at 3:30 for the next expert. Thank you very much, sir. Thank you.
Thank you for inviting us, Darshan sir and Bhargav sir. Right, it was a wonderful session and wonderful audience. Right, happy learning and stay safe. Thank you.